Why do the physical constants, such as alpha, G, and C, which are written at the back of textbooks, seem so solid and unchanging? Do they really remain the same, or is there something more to them than what we've been told? In energy filament theory, we offer a more straightforward view. They are very likely just the long-term average readings of this energy C on large scales. In the previous episodes, we've been discussing how the universe is one giant, fluctuating energy C. The tension field gives us a tightness map of the terrain, and the texture field provides the directional patterns. What's actually happening is a slow evolution of the entire C conditions. You could think of G and C as the major physical parameters of this energy C that we measure using a very coarse ruler, getting a few key metrics out of the C. Alpha is like how intensely the C responds to the request to twist the texture on the electric texture channel. G is like the average sensitivity of the tension slope to mass-based structures. And C represents the maximum limit on how fast the energy C can perform the relay action on this layer of the tightness field. The key point here is the word average. Almost all of our high-precision measurements are conducted within the same local marine region, near Earth, at similar altitudes, within comparable eras, using the same set of clocks and rulers. It's a bit like consistently measuring the average temperature in the same city over several years. You're bound to see a stable curve, which naturally leads you to call it the constant climate of this region. Energy filament theory doesn't deny this stability. It only reminds you on a deeper level that these constants are reflecting the long-term average state of the background field over time and space. We've already set up a clue in the second season. If particles are texture knots created from the energy C, then a particle's mass, lifespan, and coupling strength could also be local solutions of this C under specific conditions. There might be room for slow evolution along the extreme timelines of the universe. Then, in the third season, we added another clue. The true upper limit of the speed of light could slowly adjust with the overall tension environment. What doesn't change is the fact that what you measure with your local ruler and local clock is always the value of C. Now, looking back at constants like and G, understanding them as the average physical characteristics of this energy C in its current version doesn't seem so mysterious anymore. So, when you next encounter a long list of natural constants, try to picture them differently. These aren't magical numbers handed down from above, but rather the current phase of the energy C's overall average temperament in our immediate surroundings. Over the course of a few hundred years of experimental windows, they remain remarkably stable, just like a straight line. However, if you zoom out to the whole timeline of the universe, they may appear more like an extremely slow curve, only we haven't yet measured that tiny, gradual bend. Tap follow, share it on New Physics, Clear Universe. Let's use this series of new physics to help you clearly see the entire universe.